You're welcome to another video. I hope you're doing well wherever you are. So here we have a question involving circles, chords, and tangents. A diagram has been drawn here, and then we're being asked to find a given length xc of a chord and the length bt of a tangent. So guys, I'm going to take you through step by step and the laws and rules that involves circles, chords, and tangents. So make sure you watch up to the end. Remember to subscribe if you are new and leave a comment. So on the solution part, if you look at this diagram, we have two chords intersecting inside a circle. And the property, we have a property here involving internal intersection of chords. So if you have some two chords intersecting inside a circle, and that length I can call it n, the other one is m, the other length is a, and the other one is b, then for internal intersection of chords, then if I take a multiplied by b, should be the same as multiplying n by n, just like that. So for our case, we've been asked to find xc. If you look at this diagram, x is from here to here, and I have chord AC and chord DB. They're intersecting at x. So I'm going to apply this relationship here. So I'll take 6 multiplied by y, this length multiplied by the other side should be the same as 5 multiplied by 4.8. So using this, y now becomes 5.48, 5 times 4.8, then you divide by 6. Computing that very fast. So if I'll take 5 times 4.8, I'll have 24. Then 24 divided by 6. Of course, the length of xc will be 4 centimeters. So I've applied the internal intersection of chords. If you want to find the unknown length, then you just cross multiply the opposite sides of your chord like that. So for part B, so I've managed to find y. The value here is now 4. So part B, you are asked to find length BT. And remember this BT, it is a given tangent. It's a given tangent to this circle at point B. So you realize that tangent and a given chord meeting at point T externally, then I have a relationship that when I multiply BT squared should be equals to, if I take the length of remember here we were given 8, sorry. So if I take BT squared, should be equals to, if I take t up to c multiply by the product of t up to a, meaning I'll go from t to c, then I multiply by t up to point A. So this relationship will guide me in order to get the length bt squared. So substituting in my equation, I have bt squared is equals to t up to c, from my diagram is 8, multiply by t up to a, t up to the end, farthest end, it is 6 plus 4 plus 8. Of course, I have 18. So now my bt squared is equals to, if you're gonna multiply 18 by 8, of course it goes without saying that it is 144. So guys, remember to subscribe. Don't leave this video without subscribing, guys. Make a comment, and most importantly, like. So if I take the square root of on both sides, then my bt, the distance bt, will be equals to, if I take the square root of 144, of course I'm gonna get plus or minus 12. Then that means either bt is equals to 12 centimeters or negative of 12 centimeters. But remember, we're gonna ignore negative since we're dealing with real values. If you look at this diagram, so if you come here, we ignore negative 12 centimeters, and then my answer now becomes bt becomes 12 centimeters, which was the required length of my tangent. So when I conclude, this is what I did for the first case. You are asked to find xc, and I told you for you to find xc, you just cross multiply the opposite length of the intersecting diagonals, which we did and got our answer now as 4. For the second part, you are just multiplying the square of our tangent, then multiply by the length, external length of the chord. Till we meet again, bye.